Question 2-22 states, determine the design angle phi between members AB and AC so that the 400-pound horizontal force has a component of 600 pounds which acts up to the right in a direction from B toward A. Also calculate the magnitude of the force component along AC. Take theta to be equal to 30 degrees. Alright, first what are we asked to find? Determine the design angle, phi. So we can say find is phi, and then this we can call it the design angle. Alright, now for this question, what are we given? We know that there's a horizontal force that's 400 pounds. And there is a 600-pound force which acts up and to the right. So that means the resultant of this force will be a diagonal, just like that. Now this would be 600 pounds because it says from the direction of B towards A. So this goes from B towards A, something like that. Like that. Now, we're asked to find what this angle right here is, phi. The way we can do this is if we draw a diagram, we are able to break this problem from what something that looks very complex from this to something that's a lot simpler. Now, let's use this bar and let's use this bar and this bar as representative as the forces we have. All right, so we can draw a line from this bar from BA directly to CA. Now, the reason we can do that is because there's a horizontal force here, and I'm just shifting it down and to the left because it's essentially the same thing, right? So if I have that bar right there, let me do a little bit of cleaning up here. All right, so if I were to shift this horizontal line down, it gives me this right here, right? And then if I do that, then it gives me the force that's acting here, another unknown force that's acting here, and then this known force is 400 pounds. This formerly unknown force is now 600 pounds. Now this force right here is completely unknown. Now, we know that the top angle right here is phi, right? Now, we need at least one other angle so we can use law of cosine. Cosine law states, let's say you're looking for side C, and you know what side A and you know what side B is. So what you do is you square A and you add it to B squared. Now you subtract 2 multiplied by A multiplied by B times cosine of C. Now you might be wondering, how do I know which is cosine C, which is A, which is B? All right, here's how you can tell. If you have an obtuse triangle, so meaning a triangle that has a degree that's higher than 90 degrees, so this one right here, you can do to find the sides, you can do what's called law of sine or law of cosine. For this instance, let's call these angles, let's call this one alpha, let's call this one beta, and let's call this one gamma. Now, let's call this side C, let's call this side B, and let's call this side A. Now, which angle corresponds with which side? Now, alpha corresponds to A, right? Because alpha opens up these two sides and it gives you the side of A. Now you can do the same with the same thing with the other two angles and the other two sides. All right, now which angle belongs with B? Which angle opens up to B? So is B opened up by A? No, because alpha already opens up to A. Is gamma belong to B? No, because gamma belongs to C, because it opens these two sides up and it creates the side C. So B belongs with beta. Beta is there. Gamma, we already know it belongs to C. So that's how you can kind of sort of approximate which angle and which side corresponds with each other. Now you have to keep track of them. So typically you don't use alpha, beta, or gamma. You just use A, B, and C. But since for C it's hard to tell which one is the side C or which is the angle C, for me it's just easier to use alpha, beta, and gamma. All right, now that we know how to figure out which side belongs to which angle, now let's go back to this problem right here. So we know that this side is 600 pounds, and we know that the bottom side is 400 pounds. All right, and all we need now is just one single angle, because to use cosine law, we need two sides and one angle. But the one angle has to open up to the unknown side that we're trying to find. So that unknown angle, that unknown angle, we can say it's theta, right? Well, why would we say it's theta? So we know that this is the situation we're facing. This is theta, and then this is phi. Now, if you were to draw another line like this, and we were to fix it just a little bit, just get rid of this one right here. This angle, knowing a little bit of angles, will mean this angle is the same as this angle right here. So when we get our obtuse triangle, we know that the bottom one is theta, and we know that the top one is phi, and we know this side, and we know this side. Now we can find the unknown side, and we can also find the unknown angle. Okay. Now to do that, we have to separate the triangle from the schematic that we're given over here. So let's do this. We have that, we have that, and we have that. So this is 400 pounds here, right? And this is 600 pounds. And then now this is 30 degrees because we said this is equal to theta. And this right here is phi. Okay. Now let's just clean this up just a little bit. All right. Now let's plug this in to our equation, the cosine law. So that's 400 pounds squared plus 600 pounds squared minus 2 times 400 pounds times 600 pounds multiplied by cosine theta, because that opens up to C. So cosine of 30 degrees. This equation is originally like this. So if we want to find normal C, we just square the whole thing. Well, not square, we square root the whole thing. This would give us our answer of C. Now if you type that into the calculator, you will get 400 squared plus 600 squared minus 2 times 400 times 600 cosine of 30. You should get 322. C equals 322.967 pounds, right? But this is not what we wanted, right? We wanted to know what phi was. Now here is where law of sine kicks in. Law of sine states, sine law. Law of sine states that if we know sine alpha, we can divide it by its side, a, and it equals sine beta, and divide it by b, and this is also equal to sine gamma divided by side c. Now, let's say we know what 30 degrees and at the side it corresponds, right? So we know one of them. Now, all we need to know is one more. Now, we don't know what phi equals, but we do know the side it corresponds to, which is 400 pounds. So we know another sine. So let's set them up equal to each other. Let's say sine of phi divided by 400 pounds equals, let me see. Sine 30 divided by this number here, 322. .967 pounds. Now we can isolate this sign easily right here. So what we do is we multiply both sides by 400. This gives us sine phi equals sine 30 times 400 pounds divided by 322.967 pounds. This eliminates pounds and it gives us a unitless answer, which is perfect because all we need to do now is just do sine inverse of sine phi, which will give us phi, which is equal to sine inverse of sine 30 times 400 divided by 322.967, and phi is equal to sine 30 times 400 divided by 322.967. Phi is equal to 38.2619 degrees. And just for fun, you can find this angle right here. All you have to do is you get 180 degrees, subtract phi, and subtract theta. And you know both of them already. And this is equal to, see, 180 minus 30 minus 38.2619, which gives us 111 degrees. 7381 degrees. We box in our answer. And we box in our second answer.